All right. Oh, it's good to be back. Isn't it good to be back? So, just some audience participation to keep you awake. First off, how many of you are here for the first time at NACIS? Welcome. I doubt it will be... Sorry, I'm supposed to talk into the microphone. I doubt it'll be your last time. For the rest of us, how many of you have been to a NACIS before and been totally inspired by something and gone home thinking, I have got to try to find an excuse to do that? Of course, that's why we come, right? That's why Dennis and I have been coming to this thing since before half of you were born. So, now, of those of you who raised your hands, how many of you, your second thought was, oh, but I don't have the skills or the software or the tools or the talent to do that. How am I going to replicate this that I saw? Okay, last question. Keep those hands raised. How many of you is it something that Tom Patterson showed? Okay, yes. So that's what I'm going to be showing today is something that just trying to find a way to make something. Let me take this off. Okay. Finding a way to kind of get what I want with the tools that I have to use. And so that is, I think, what a lot of us do in cartography. So a little bit about the background of this. My son and I, that's one of my sons, he's a filmmaker, and we are currently working on a project called the State of the BST that we are hiking this trail, this long, kind of important trail in Utah, and then producing a documentary series about it, about the trail. Just a little bit about this project. The red line there is the Bonneville Shoreline Trail. It runs the length of the Wasatch Front, which is the big kind of urban area of Utah. About 150 miles as the crow flies from the southern end of Utah Valley to the Idaho border. And it gets its name because it generally follows the shoreline of the Pleistocene Lake Bonneville, which, as it was at this higher level, left this really nice sandy bench, which makes a really nice place to put the trail. And because we live against a fault line, we have these tall mountains that right up against us, right against the city, so it forms this really nice urban wildland interface where you can hike this trail and have wilderness on one side and city on the other side. And it's just a great place. But it's taken a long time, and this talk is not about this trail, but it's taken a long time to build it. Right now, the current plan is almost 400 miles long. It's going to get longer before they're done, but only about 130 miles are done. So that's kind of our project is documenting what is done, what is not done, what's taken it so darn long. So this is the product that we're doing. Now, this is not meant to be a navigation aid. We've got a web map on the website that does all that stuff that you can zoom in and get all the details. This is mainly to give trail enthusiasts and decision makers a kind of an all-in-one idea of what the overall trail looks like and what its current status is. So, because I like big maps, we wanted to do it as a poster. So that's the finished product. It'll be in the gallery. And part of the constraints to this is we needed to do this in ArcGIS Pro because of the nature of the data and some other things. So that's kind of was our constraint, that we had to get it done with this particular piece of software. So, over the years, like a lot of you, I've done a lot of 3D views, and this is yet another 3D view, and I've used a lot of different kinds of software to do it. I think one of these is Natural Scene Designer. I think that actually might still be around. And there's a SketchUp in there. So this is not meant to do that. It had some uniqueness to it. One of the unique things is, because the trail is so long, so like I said, 150 miles as the crow flies, that if you tried to do this in kind of a typical, Google Earth or just a globe kind of panorama, the problem is that the trail and kind of the area of interest, that is the trail and the mountains and the city, are just this very narrow band across the middle, and most of the map is taken up by stuff in the background that isn't really all that interesting. So this goes all the way to the Colorado Rockies, which is just not part of the story at all. So my inspiration was this map. Oh gosh, it was probably 20 years ago that Tom presented how he did this map for the National Park Service, which is still in use, I believe. And the idea behind this is not a natural perspective view. It's been foreshortened, so quite a bit. So the front part of the map seems like you're almost looking straight down at it, more map-like, but the back part of the map, the top half, has been rolled over, so it looks natural, but it's actually much more extreme, so that by the time you get up to the North Rim, it looks like you're looking straight across, like the view you would see if you were standing on the South Rim. So I've wanted to do that for years and remembered how that he had done that, but I don't remember what tool Tom used to do that. I had to do it in ArcGIS. So I'm going to talk a little bit about kind of what I did here. So the first thing was to create a raster grid covering the area that is basically just the UTM-X coordinate. Okay, so start with that. That turned out to be a lot trickier in ArcGIS than I thought it would be, but that's what I did. Then what you do is you roll, essentially, the DEM. So I used that X, basically turned that into a curve with this formula here, and added the DEM to it. So you can kind of see how it drops off on both sides significantly. And if you look really carefully, you can kind of see the terrain hinting in there. But the terrain elevation difference is not nearly as much as the actual curvature. Getting that curvature just right takes some work. So if you look at the section on the left there, that's what it would look like with no roll at all. So essentially a flat surface. You can see how most of the map is taken up by stuff in the background. If you look at the far right, you can see that's way too much. Everything looks really warped. It looks really artificial. It does not look at all natural. So those two in the middle is kind of the range of what we were looking for. I liked the 1500 one there, but I ended up going with the 1000 because it just focused a little more space on the actual area that we're interested in. So the second kind of trick that I had to come up with to get this to work, because this is such a wide thing, the problem is that as you take typically a normal focal length camera on this, the ends are really distorted. So they're really coming in like this on the ends. And I wanted to have kind of a similar idea, similar view of the whole length of the trail. So it wasn't really distorted on the ends. So what I did for the bottom one is just a fairly simple thing, is I reduced the focal width. So this is actually a field of view of only 19 degrees instead of 55 degrees. So it's very telephoto lens essentially. But that meant I had to zoom back. So this is the view you would get, I guess, if you were over in space, somewhere over the Pacific Ocean with a high-power telescope looking at Utah, right? You would see this. And if you look carefully, you can see that out there on the ends, it's not nearly as distorted. It's much more kind of almost vertical on this. So that way they get kind of a fair representation at the ends is what the middle gets. The next step was to just add some haze to this. That was a fairly simple process, just basically taking that X grid that I had and then coloring that so that it was completely transparent in the foreground and a solid, in the background on the west end, it was a solid sky blue, and then just fading the transparency as you went back. As you probably note here, I had a lot of advantages that because the trail goes due north and south, the view is looking due east. Tom had the advantage of looking due north. If you were at some odd angle, this would be a lot more complicated math. And who wants to do that? So always find a subject that goes due north and south. The last problem that we had was something built into ArcGIS Pro, is that it's very much tuned in the 3D view, which is really cool, but it's very much tuned to the screen. So it always renders at the quality of the pixels on the screen. So it's, even if you export at a really high resolution, the actual quality of the raster layers and the vector layers and the terrain surface are all at the resolution of the screen. And there are, unless somebody from Esri wants to point this out, I couldn't find any settings for changing that. It seems to be built in that that's just what it does. So this is what I want on the left, but that's what it does on the right. So I cheated. I just took two 4K monitors, stuck them together, and then stretched ArcGIS across both screens. It was slow, but ArcGIS doesn't know the difference. It just thinks I have a monitor that is that wide. And so it was rendering at that pixel depth. And so it was rendering at that resolution. You can see in the background, the finished map is about the same width as these two monitors. So that ended up getting a decent size, a decent quality for the render. And that just led to the finishing touches of putting some stuff on it. The labeling, I wanted to keep the labeling to a minimum because who wants to get in the way of all that beautiful terrain? So that just did some of that in Illustrator, and that was it. So thank you.